Hello, and welcome to the Trepid Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 3.5 Secure Mobile Solutions. Now let's get started. In today's workforce, there is a lot more freedom of movement for your employees, and it is essential as security administrators that we look at all the vectors of possible attack. This includes all our mobile solutions, connections, and mobile devices. Cellular networks are used every single day by people. In today's society, we're glued to our phones, which connect us to the internet using cell towers and cellular networks. Cellular networks are considered inherently secure because of the ISPs that manage them. However, if you implement a zero trust policy in your enterprise, you should have some security measures that prevent sensitive information from being accessed over a cellular network. Some organizations will also choose to only allow downloads and updates from the corporate network and will not allow employees' corporate cell phones to download anything from a cellular network. Near-field communication is another connection method used in short-range transmissions. It is very low power and commonly used to support payment methods like Apple or Google Pay from your cell phones. Infrared is an outdated form of transmitting wireless signals, but we have to learn about it because it's in the Security Plus exam objectives, and it uses lasers for transmission. A USB is a small device that can store large or small amounts of data. USBs are handy tools that can be used for offline transfers of data. However, for your enterprise, USBs can be deadly. A USB can house malicious software that can spread and infect your enterprise when plugged into a system on your network. USBs can also be used to bypass network filters and exfiltrate sensitive data. DLP is a way to prevent that from happening. RFID is a short-range wireless technology used to track and tag personnel or equipment. RFID is the suite of technology used in badging systems as an essential part of your organization's physical security program. GPS is a global satellite constellation that provides us with real-time positions and geographical locations on the Earth's surface. GPS is a great technology that has made our lives easier in ways we probably couldn't even imagine 50 years ago. We now can navigate anywhere in the world using GPS. For your enterprise, there are also use cases for GPS-related technologies. Geofencing is a technology that will restrict the use of mobile devices to a logical GPS field created by the security team. Geofencing is typically implemented when an organization wants to keep company mobile devices restricted to a city limit or to the company compound. Geolocating allows you to locate devices anywhere there is a signal. GPS also has vulnerabilities in wartime. GPS can easily be jammed and spoofed by our adversaries. So not too important on the Security Plus exam, but GPS is very easily jammed because the satellites sit in low Earth orbit and their frequency ranges are easily available. So much so that even a battery-powered jammer, like I'm talking D batteries, are able to jam Garmin GPSs. Now let's go over mobile device management. Mobile device management is a concept and software suite installed on mobile devices to secure them for enterprise environments. MDM should always be used if company data will be processed on personal or company-issued mobile devices. Application management is a feature that allows the enterprise to control what applications can be installed on mobile devices. Application management can also be used to only install work-specific applications. So if we use application management on our workforce's mobile devices, right, we can easily allow enterprise solutions to be installed on their device and also prevent distractions like social media from being installed. Content management, also called MCM, ensures access control of an organization's sensitive data on a mobile device. MCMs will lock business data into a secure file system that only approved MDM mobile device management applications can access. This is sometimes referred to also as mobile sandboxing. Remote wipe is another technique an enterprise can employ to protect their data on mobile devices. Remote wipe allows the security administrator to delete files on the phone system from an application that can be controlled remotely. A remote wipe can be used if the mobile device has internet access. If a phone has been stolen, a remote wipe is an option to secure your sensitive data. However, there are some things you need to keep in mind with remote wipe. If the person who stole your phone takes it offline, then remote wipe can't be activated. As you can see here, this is like a remote wipe application. But if it can't find your phone because they put it on airplane mode or just turned it off, and that was your only protection mechanism, then that data is not secure, right? So remote wipe cannot be the only thing you implement to secure your mobile devices. Screen locks will protect your phone from being accessed by any unauthorized party. MDM software can also place parameters on the complexity of the PIN or password used to unlock mobile devices. Biometrics can also prevent unauthorized persons from accessing your mobile device. We've talked about this in previous videos with Face ID or using fingerprint scanning on, let's say, the Apple iPhone or some Android phones. Push notifications can also be used as a second form of authentication and can be used in MDM to alert a mobile device that it has been stolen. So think about this, right? Let's say your device has been stolen and someone has it online. From your MDM software suite, you can send a push notification to the device, letting the threat actor know that you know it's been stolen. Pretty cool, right? MDM can also be very granular in its approach to authenticating a user to a device. Mobile device management can also use context-aware authentication for adding restrictions to logging in. This could be deviations from behavioral elements, location, or time. So essentially what this is saying is we can even be very granular in our approach with MDM, that if we notice a user's device is going to websites it doesn't normally go to, or logging in at certain hours that it normally doesn't, or has impossible travel times, right? Then we can lock down that device. And then we have containerization. A container is used in mobile device management to wrap enterprise applications and run them without interacting with the host mobile device. This is a form of virtualization that we can implement to protect our enterprise data applications on mobile devices. Storage segmentation separates personal and enterprise data into different folders or volumes on your mobile device. This can be done using containerization or through encrypting certain volumes that can only be accessed by company credentials, right? Full disk encryption will protect your mobile device's data at rest. The entire device can be encrypted and will only become unencrypted after inputting your mobile device's PIN or password or unlocking it. This is the protection you want to use against theft for your mobile devices. Because just because someone steals your phone, if they can't log into it, they can't get access to any of the data. And then we have unified endpoint management. This is just a platform for device management. UEM can manage both Android and iOS devices. And then we got some more mobile device features or peripherals here. Mobile devices can also have hardware security modules. Mobile devices can use micro SDs as their HSMs, make it a small form factor for your mobile device, and giving it that HSM capability to create, backup, store, and manage encryption keys. Then we also have a very important function for Android devices called SEL-Linux or SE Android, which provide the ability to enforce mandatory access control on mobile devices. With SE Android or SE Linux being enforced, you can implement policies on any Android mobile device, which you cannot just do with a standard Android phone. SE Linux and SE Android have two different modes of operation. Enforcing mode enables the policies to be enforced on the mobile device, where permissive mode does not enforce the policies and leaves the phone's policies at factory default. So this is just a way to do mandatory access control to pretty much put security policies on a phone similar to how you would on a computer. And this is something specific to Android. And the two modes you got to know is enforcing mode, which will make SE Android do those policies that you set, or permissive mode, which will not enforce the policies. And let's go over some different deployment models for our mobile devices. So we have bring your own device policy, which have users use their own devices to access enterprise services. Now, this can be a risky implementation because you cannot control everything a user does on their device. However, you can have users sign an AUP and onboard their devices into the company's mobile device management systems. Now, with that AUP, that acceptable use policy, that is essentially saying that the user will agree to having that MDM solution being installed into their device and to be managed, right? Now, this is the cheapest solution for organizations doing a BYOD, but also carries the highest risk because at the end of the day, it is still their own device, right? No matter how much wrapping you do or virtualization you can perform on the phone, there's still the chance for data exfiltration or it getting stolen, right? And then we have COPE, the corporate owned personally enabled device policy, gives the organization the most control over user devices. However, this is a more expensive solution. Employees will still be able to use the phone for personal use. Most of the time, a COPE deployment, social media applications will not be installed though, unless the managers in the company allow social media to be installed on the phone. So essentially what this is the enterprise being in full control of the phone and the management of it. But the employees can still use it for personal use within reason, right? They can text, they can call, but maybe they won't allow TikTok or Instagram to be installed. And then we have a choose your own device deployment. In a choose your own device deployment, the organization owns a phone, but the employee chooses what phone they want to use from a preset list. So the company will say, hey, we got an Android, an iPhone, we have Samsung, LG. Which do you want to use, right? And then in a fully corporate owned deployment, the end user will have no say in the functionality or type of phone they will be using. Essentially, this is it's similar to COPE, except there is no personal use. You are using this phone for email, for accessing files, and that is it. And then we have enforcement and monitoring. So sometimes an organization will restrict users from using the phone's vendor's app store. So Apple Play, the App Store and Apple or the Google Store, right? And instead implement a third-party application store that the company will provide. This allows better control for the organization as they decide which applications can be installed onto a device. An organization can also enforce how the applications are installed. They can deny applications for being installed from cellular or home Wi-Fi networks, and they can only allow applications to be downloaded and installed while the phone is connected to the corporate network or the corporate Wi-Fi. Rooting or jailbreaking a phone will give end users access to admin controls and features they're not supposed to have on a phone. And now let's go into some more application installs. Sideloading is a method to bypass the authorized app stores or the OEM app stores to install unauthorized applications on the device. Sideloading can be done via USB or micro USB, and sideloading can be used to install custom firmware onto a device, right? So like the Apple Store only allows applications that are approved by the Apple Store, right? But if you want to put an application that isn't approved on there, you can use sideloading. Carrier unlocking is the process of unlocking your phone from a specific carrier and will allow your phone to roam on different cell services. All right, and then we're going to end this video by just going over other monitored mobile features. So these are just all the features that can be managed with MDM solutions, right? So you have everything here: camera use, text messages, GPS tagging, tethering, hotspot, payment methods, right? Just a list of examples of stuff that can be monitored. All right, that is all for this video. I want you to stay tuned for our next video where we will go over domain 3.6 cloud security. Thank you for viewing.